Okay, I'm going to show you how to generate an M20 nut and bolt. Okay, so first of all, I'm going to go to this search icon here, and into the search window, I'm going to put thread. And I want to take this particular object here and put him down on the work surface. Now, first thing I want to do with them, before anything else, let's just put this into orthographic view and look at it from the front. And you can see that it's not sitting flush with the work surface, so I just want to do this drop to work plane to save any problems later on with it. Okay, now we want to set the parameters. So the diameter, because this is an M20 bolt, we want a nominal 20mm outside diameter. Pitch 1.5 standard coarse, so we leave that as it is. Segments, that's how smooth it is around the outside. I'm going to put that up to 32. Rotations, this is effectively the height, because if you want to work out the height, then you take the number of rotations and multiply it by the pitch, which is 1.5mm. So in this case, this would be 7.5. We're actually looking for a height of around 20mm, but because 20 doesn't divide by 3, we'll make it 21. So if we put 14 in here, then 14 times 7.5 will give us 21, and there's our height 21. Okay, tip scale we'll leave alone, it's not really important. Tip segments controls how gradual this lead-in is here, and what I'm going to do is I'm just going to step that up to 5 from the default of 2 there, and you'll see the change that's now smoother up there. Okay, now that's effectively the thread part finished. All apart from it needs a means of turning it, which for that we're going to need a hex bolt head. So I'll kill off this window, and then I will go to this hex object here, pull him from the display, and now the distance across flats that's standard for an M20 bolt is 30. Okay, but because of the way in which this is this doesn't just apply to regular hexagons, this shape, I'm going to have to put in 34.6 here, which I found doing a bit of simple algebra, which I won't go over just now. Okay, and now for this height, where are we there? I'm just going to make that 10mm, so it's half the length of the thread. Okay, whoops, didn't go in there. There we go. Now, next thing I want to do is, just one other thing. This is just a bit of a nicety, but you've got bevel control here, and I'm just going to put bevel on here of 2. And that sort of looks quite nice and engineering-y. Okay, right, now, if I select both these parts together, then I can push the align button, and I can align these in both horizontal dimensions like so. Okay, and then making sure they're both selected, I'm just going to go and do a union group to them. Okay, and that's made us just one single component there, and that's our finished bolt. Very nice. Now I want to move on, and I want to make a nut, but obviously it's easier to reuse this. So what I'm going to do is just select it and hit duplicate, and then I'm going to pull this duplicate copy away. Then I'm going to ungroup it next, because for one reason or another we need to separate it out. So I want to take the nut part and move that away. This is the part that's going to cut out the thread from the nut, so we need to make some changes to that. Now, first thing is that it needs to actually be, you need to provide clearance. In this case, whereas if you were dealing with metals, you'd probably you'd be working with tables to try and tell us what clearance you would need to provide and how you change the diameters. In the case of this particular one here, your only real alternative is to find it by iteration, and sizes can vary quite wildly because of the fact that the polymers have a tendency to shrink and contract as they cool. So anyway, I know from experience 21.6 works very well with these particular other dimensions. Okay, so that's just made that little bit added that little bit more diameter on that. Now, we have one other issue with this, which is that if we look at it from the front view, you can see here that the threads don't go right to the end because you've got this lead in, and of course, whereas it might work well for the shaft, it's going to be fatal for the nut not to cut this bit of thread here. So what we're going to do is just augment out around here to add some more material that's going to be taken away, if you see what I mean. So what I'll do is I'll go up and I'll take a cylinder here, and I'll set the height to just 1 rotation, which is 1.5. Okay. And the diameter, I'll just set, which needs to be set in the two places, because this is, of course, actually really more of an ellipse than it is a circle in itself. So there we go. And then what we'll do is we'll get these two components and then we'll align them together. So in both horizontal dimensions, okay. And then we'll select them both together and then we'll make a union out of them. Then what we'll do is we'll click this again and we'll make it into a hole, okay. Now we want to combine this with the hex nut part, okay. So once again, we want to go into a line and align them in both horizontal dimensions. So there we are. And now all we need to do is, if we get these and then we make a union out of them, there it goes. There goes the hole through there. So we've got a very nicely cut nut thread there. Okay, now I'm going to put these both next to each other because when we send it to the 3D printer, we might as well print them both at the same time, and we want to save the printer the legwork of having to travel a long way between the two. So now I'm going to go into export and good old STL, the standard format for all of these things. So that's it, prepared for Mighty Alice is prepared for export, so we'll save that. And now if we go over and into Bambu Lab and we go to import, there's Mighty Alice, bring it in, there it is. So then I can slice that. Okay. And now we can click print and off it goes. So see you on the other side. So here's a few examples I've made, and they fit together pretty well.